DNS Exam 2, problem number 14. They told you here that you've got two differentiable functions for all real numbers here and asked you which of the following four definite integrals was equal to this expression right here. It's a composition of two functions, f and g, and we've got 4 and 2 as the two values at which those are being evaluated and subtracted. So what I was hoping we would recognize almost right away here is that this expression looks like what we would get from the end of using the fundamental theorem of calculus part 2, which is kind of the way then that I look to approach this one. So what was going on right here? This is the expression that we were given here initially in the problem, f of g of 4 minus f of g of 2. And so that looked like what we would get from taking a definite integral from 2 to 4 of just some other function out here. The integrand is currently unknown, so I called that h of x with respect to x. That would get us this expression right over here, and this would be just another way of expressing that same thing. Usually when we talked about fundamental theorem part 1, we would put this expression here in the middle and then go to here. But the point is, we're trying to figure out what function right here, h of x, would be our original integrand in order to get us this expression right over here. So, in thinking about how we might try to approach that, basically what's going on then is that if we have a definite integral right here that's equal to this expression over here on the right, that the integral or the antiderivative of h of x would equal f of g of x, we could get rid of this integral by taking a derivative on both sides. So in essence, what we kind of did here is did a derivative with respect to x of that left expression and balance that out by doing a derivative with respect to x of that right section. So if we ignore the fact that it's a definite integral, the derivative of the antiderivative of h of x, which would just be h of x, would get us the derivative, or be given to us by the derivative of this expression right over here, f of g of x. And once we make that leap right there, it's not too hard to realize what kind of problem this is. They just want us to see if we can take the derivative of a composition of two functions. So if we remember how to do that from the end of chapter 3, we start by taking the derivative of the outer function. The f gives us an f prime, but the inner function, g of x, stays the same. But then by the chain rule, we multiply by the derivative within, so that's the times g prime of x at the end of all that. So that is what h of x is equal to. That's our original integrand. And so what we can see here is that the expression that they gave us right here is equivalent to the definite integral from 2 to 4 of f prime of g of x times g prime of x taken with respect to x. So we can see there that the answer is C.